All right, so we're going to talk about a few other adaptations to aerobic training, specifically three things. So lactate threshold, RER, and oxygen consumption, and then same with the previous videos, why these changes are beneficial. Okay, so the first one I want to start off with, and we're going to spend the most time on this, and it's only a couple slides, is lactate threshold. So a couple of things that I want you to remember is that one, lactate does not cause fatigue or soreness. Two, I don't have it on the slide, lactic acid is not a thing in the human body. It exists in sour milk. Your blood is nothing like sour milk, so there you go. Lactate's actually our friend. It acts as a buffer. Okay, it takes the hydrogen ions that are produced during glycolysis and gets them out of the cell, and then lactate goes into the bloodstream. Okay, now with that, there is a correlation between pH and lactate production. Okay, and lactate, once it gets out into the bloodstream, there's a couple things that can happen to it. It can go into the liver or the brain or other parts of the body and be taken up and utilized as fuel, right? We have the Cori cycle where lactate goes to the liver, is converted to glucose, and then that glucose can be used for other things. It's important to know lactate does not appear to cause fatigue. It is correlated with fatigue. There's a big difference between correlation and causation. Okay, so just because we have a correlation or a relationship, that doesn't mean one causes the other. Okay, and so what we have found, what a lot of research has found, is that this lactate threshold, which is this point right here, and then right here, for each of these people, or I guess in each of these conditions, that's the point where lactate goes from staying relatively constant, which means the amount that I'm producing is balanced by the amount that I'm clearing out or taking up or utilizing. Okay, but when we get to this point here, this inflection point or this lactate threshold, that's when fatigue starts to set in. Okay, it's not completely understood why why there is this relationship with lactate and fatigue. Okay, but like I said before, lactate's not causing the soreness, it's not causing the fatigue, it's just correlated. It's interesting to note that in most untrained individuals, this buildup of lactate, which then makes it easier to fatigue, or is linked to the ease with which you get fatigued, it occurs around 50 or 60% of VO2 max. Whereas in trained individuals, it can be 80% or even higher, okay, which means elite athletes can train at a ridiculously high intensity and go for a very, very long time, okay? So how does aerobic training affect this or cause this, that sort of thing? So it results in two things. One, we reduce the amount of lactate that we're actually producing. We're able to rely on those oxidative systems longer, which is great. And then two, we are able to clear it out better. Okay, so we can take that lactate and we can convert it into glucose in the Cori cycle. Like I said, your brain will take it up and use it as energy. There's several things that can happen to increase clearance. And so I have lower production and increased clearance. That's going to make it easier to maintain blood lactate for a longer period of time. And as I said, there is a link or a correlation or a relationship, an association, however you want to put it, between lactate threshold and aerobic performance. Many, not all, but many aerobic athletes will train at a lactate threshold. And what that means is that they'll train right around here. So in this trained athlete, maybe it's, we'll just say it's 75%. They're going to train at an intensity that elicits 70, or that is at 75% of their max. That means they can put in some high intensity training, get all the other benefits that we've talked about, which will then help them like when they go do races and stuff. Okay. Whereas if they train up here at 85, they're not going to be able to train for as long. Yes, it's a higher intensity, but they won't be able to train as long. Their workouts will be less. And there are times where that's beneficial, but there are times where you need to go for a longer duration. Okay, so the next thing is RER. So remember, RER is the relationship of carbon dioxide production to oxygen consumption. And we can use this as an indicator of what kind of fuel source we're relying on. So generally at rest, we're at 0.7, which is completely relying on fats. We get up to high intensity, maximal exercise, our RER will be at 1, which is a high reliance or complete reliance on carbs. Okay, so with aerobic training, what happens is we rely on fats. We're able to utilize fats for a longer period of time, and as a result, for a given intensity, our RER is longer. This gives us a buffer so that we can train or we can work at a higher intensity later on. And then lastly, VO2 max, and we're going to talk about this with the last video, but VO2 max increases after training. You're going to be able to utilize more oxygen. And as we've gone throughout this unit, hopefully you've seen where these changes can come from, both respiratory, muscular, and cardiovascular from those systems. As you probably are aware, untrained individuals are going to see massive gains in VO2 max. They'll see massive gains in everything relative to somebody that's elite. Okay, so just think about people that go to the Olympics. They train and train and they train all for a 4-year cycle, and if they're fortunate, they'll take off 1 or 2 seconds or whatever it is in their mile time. That's not very much. But if I take one of the people in the class that hasn't run, maybe they just run and put them through a short training program, they're going to see several seconds, maybe minutes come off their mile time. And so when it comes to VO2 max, there's a lot of different ways that we can accomplish this. Okay, so I'm just going to keep this chart up here, but notice we've got the cardiovascular. A lot of this is cardiovascular, but there's some muscle, there's some respiratory. There's all sorts of different ways that we can improve our VO2 max. And we'll focus on that with the last video of this section.